Good morning, 9th standard. So, today we will be learning about chapter 4, pressure in fluids and atmospheric pressure. So, the word pressure is known to you from your 8th standard. So, before going into it, let us have a recap on it, learning what is a pressure and its SI unit, CGS units. I always used to tell you, whenever you learn any physical quantity, it is mandatory you have to learn its units, okay, and you have to find whether what quantity it is it's a vector or a scalar quantity. So before going into it, let us have the connection between thrust and pressure. So what do you mean by thrust? Thrust is a kind of force which acts on a body. Force can act on a body in any direction, but if at all it is going to act in a perpendicular direction, that is at a 90 degree, then we specifically term as it is thrust. Okay, we call that to be as your thrust. So thrust is a force acting normally on a surface. Normally here means 90 degree. For example, I'm having a box at 90 degree, a thrust is going to happen. This is your 90 degree, yes or no? So at 90 degree, if any force acts on it, it is called as your thrust, even in this direction, which is 90 degree to me. So here they also claim that in whatever position, the thrust exerted by a body will be equivalent to the weight of your body. The thrust exerted on a body, the thrust which you are going to apply on the body will be equivalent to the weight of your body. So as we go into this lesson, we will see what is and how the thrust and weight are getting connected, because the formula for your weight will be mass into acceleration due to gravity. So we will see how it is working. So as of now, just note it down. So thrust is a vector quantity, because here we are noting down its direction, perpendicular, it is a direction. So here it means a vector quantity. Next one, the units of thrust. So it is measured in the units of force, because it's a force, yes or no? Thrust is a force acting in a perpendicular direction. A force which is acting in a perpendicular direction is termed as thrust. I'm going to give a specific name because he is acting in a perpendicular direction. Therefore, it's nothing but your force. So whatever units you're going to use for your force, the same units you're supposed to use here. So now think about the units of force. What is the SI unit of force? Yeah, it's Newton, and the CGS unit is dyne, and the relation between them, 1 Newton is equal to 10 power 5 dyne. So that you have to remember. Next, our major quantity, that is the pressure. So pressure is nothing but this particular force, okay, the force which is acting in a unit area. So now I'm going to apply a force in a small area, or I'm going to apply in a very large area. So that is called as your pressure. Thrust which is acting in a unit area is called as my pressure. Unit area means like 1 meter square, something in terms of 1. Or simply pressure is nothing but thrust by area. So the major fact is, if I'm going to apply in a small area or in a larger area. So imagine I'm going to take a small object as well as a larger object. If you're going to, so let us go with the example which is given here. A loose sand. Loose sand means a sand which is near the seashores or in your riverbeds. So they are typically loose in form. So if you try to walk on them, you will find your foot already sinks into it. But in the same sand, if you're going to lie down, you will not sink. Why? Have you ever thought about it? The same. If you're standing also, your weight is going to be the same. If you're going to lie on the ground also, your weight is going to be the same. Then why in first case my feet is sinking into the ground, but when I'm lying down, I'm not sinking? Why it is so? Because the same thrust is acting in a different area. The same thrust is acting in a different area. So if you're standing in a piece of a small, this is how you will stand, yes or no? This is your floor. I mean, in your loose sand, if you're going to stand, this is the area which you can accommodate. But if I'm going to lie down, this much place I will accommodate, yes or no? So this is a smaller area and this is a larger area. If I'm going to stand, a man is standing here, his weight will be, let me take 50 kg, same. And a man is lying down, and now what is the weight will be 50 kg. So your thrust is same, but the area is different. So area here is smaller and the area here will be bigger, and accordingly your pressure will differ. So therefore your pressure formula is nothing but thrust by the unit area. So now think about, as your area is going to decrease, what happens to my pressure? Area decreases, your pressure increases, because they are inversely proportional. Area decreases, your pressure increases. Okay, look here. Pressure is equal to thrust by area. Let me take my thrust is equal to 50 newtons. Area, I'm going to use two areas. One is 10 meter square, and the another area, let me take it as 20 meter square. So this is a condition. So for a given thrust which is going to act in two different areas, let me calculate my pressure. So first one is 10, the another one is 20. So pressure in case of my first area, pressure is equal to thrust acting on my area. Thrust is 50, and first case it is 10. So 0 and 0 will get cancelled, you will get 5. And don't forget the units. What is the units? Newton by meter square. Let me calculate for the next one. So pressure is equal to thrust by the area of 2. So again 50 by 20, I used 20 I think. So 0 and 0 will get cancelled. What is the answer here? 2.5 Newton per meter square. So you can see, as your area decreases, the pressure increases. As your area decreases, pressure increases. We call them as inversely proportional. For pressure and area are inversely proportional. If this is going to increase, this will decrease, and if your area is decreasing, your pressure will be increasing. This is the inverse proportionality between them. So come back to the SI units. SI units, pressure is equal to thrust acting in a unit area. What is SI unit of thrust? Newton. What is SI unit of area? Meter square. Therefore Newton by meter square. Or else we can also use one more unit which is called as your pascals. You will use another unit which is called as your pascal. And your CGS unit, dyne by centimeter square. Dyne by centimeter square. As I told you, 1 pascal, okay, Newton by meter square. Instead I can term it as 1 pascal. So 1 pascal is nothing but 1 Newton of force which is acting in an area of 1 meter square. So that is your 1 pascal. So the relation between your Newton, CGS and SA, 1 Newton meter square will be 10 dyne centimeter square. Now you have to think, how does we got the value 10 dyne centimeter square? So think about it. What is 1 Newton equal to dyne? It is 10 power. So 1 Newton is nothing but 10 power 5 dyne, and 1 meter is 100 centimeter. So using this we will try to obtain the relation between them, because if at all you forgot the relation, you can directly solve them and obtain it. That will be much easier. So first you have to write your SI units. 1 Newton by 1 meter square. So I have to convert into my CGS. So what is 1 Newton? 1 Newton is 10 power 5 dyne. 1 meter is 100 centimeter. Therefore 1 meter square is 100 into 100 centimeter square. So now if I cancel, can I cancel it now? What it will be? 10 power 5, 10 power 4 dyne by centimeter square. So what will happen to the powers? 10 power 4 will go to your numerator. Therefore it will become 10 power 5 minus 4, which is 10 power 1 dyne centimeter square. So this is how we got our units. So instead of memorizing them, you can try to obtain this might be helpful in future. So here you have some other units. Can you see the atmospheric pressure? So this unit, okay, the atmospheric pressure unit, so the pressure which is prevailing our atmosphere, which is inside our atmosphere, this we'll be using in your next sections, I mean in section B. 4b and 4 we'll be using here. So as of now, just note it down them and I'll explain you during that part. So if I tell it, you might get confused. And factors affecting the pressure, what is your pressure formula? It is thrust by area. So just now we saw how does it will work. So thrust by area, how it will be working. So an application of it, larger the thrust acting on a given area, greater is the pressure. So it's a simple logic which works behind them. What is your pressure formula? It is thrust by area. So pressure and thrust are directly proportional. Pressure and area are indirectly proportional. Just now we saw. So if I am going to increase my thrust, I can increase my pressure. Yes or no? If I am going to increase my thrust, if I'm going to put more force, therefore my pressure will increase. Similarly, if I decrease my area, my pressure can increase. Make your area to be very small. If you're going to make your area very small, therefore your pressure can easily increased. So these are the application, the ways to increase your pressure. If I want to increase the pressure in an object, either I have to apply a more thrust or I have to decrease my area. So we will see how does it works. Here it is given. For the given thrust, the pressure on a surface is increased by reducing the area. So application is, the ends of your nails are made pointed so that the large pressure is exerted through the pointed ends and they can drive into a less effort. Similarly for your knife, the cutting tools also have either a sharp edges, so they can, small thrust may cause a great pressure. Can you understand why is your ends of your knives are made sharper? You apply a very small force and it can make a severe cut. So these are your ways of increasing the pressure. And how do I decrease my pressure? The opposite of it, decrease the thrust, similarly increase your area. So this is how we do them.